Hello students, welcome to the channel of Vedant classes. Okay, so in this lecture we will see few formulas of derivative and then we will solve the questions regarding the differentiation. Okay, so let's start with the first formula. First formula is dy dx of k is equal to 0 where k is any constant. Okay, so differentiation of constant is always 0. For example, differentiation of 5 is 0, 10 is 0, the differentiation of 100 is 0. So likewise, differentiation for any constant term will be 0. The second equation, second formula is dy dx of x raised to n. So it will be nx raised to n minus 1. Remember this formula is very important. Then third one is dy dx of x, which is always equal to 1. Okay, it is just a special case of the formula number 2. You can see dy dx of x raised to 1, so it will be 1 x raised to 1 minus 1. So anything raised to 0, it will always be 1. Okay, so for this reason its answer is 1. Now let's see the fourth formula, d by dx of root x. Okay, so d by dx of root x is always 1 upon 2 root x. So d by dx of root x means x raised to 1 by 2, so it is 1 by 2 x raised to 1 by 2 minus 1. So it will be like this, 1 by 2 x raised to minus of 1 by 2. So for this reason it is 1 by 2 root x. Okay, x raised to minus 1 by 2 is 1 upon root x. Okay, now let's see the next formula 5, d by dx of k dot f of x. Okay, so in such case, if it is like this 5x, okay, so you need to keep 5 aside and take out the derivative of x only. So it will be k d by dx of f of x. Okay, sixth formula is very important rule, d by dx of f of x plus or minus g of x. Let's say any two functions are given as a sum or as a difference. Okay, so you can apply the derivative to both the terms individually, both the functions individually. D by dx of f of x plus or minus d by dx of g of x. Okay, now seventh, again most important rule, it's called product rule. Seventh rule is product rule. It is d by dx of product of two function f of x dot g of x. Now remember the formula. First of all, you need to keep f of x as it is and carry out the differentiation of g of x, plus then keep g of x as it is and carry out the derivative of f of x. Okay, so just like this you can calculate when two functions are given as a product. You can find out the differentiation using this rule. Again, each rule is important. It is called quotient rule. Okay, so in this case d by dx f of x upon g of x. So remember the equation, g of x whole square, up in numerator you need to write g of x dot derivative of numerator minus keep numerator as it is and carry out the derivative of denominator. So this is very important equation to find out the derivative when two functions are given as a numerator in terms of numerator and denominator. Okay, so this rule is very important. Okay, now let's see the next important equation. It is of logarithm, d by dx of natural log of x. So answer is 1 by x. Okay, then remember the next two. 10th, d by dx of sin x. So derivative of sin x is cos x. Okay, then let's write the next number 11, d by dx of cos x. This will be equal to minus of sin x. In 12th, d by dx of exponential function. It is exponential function. the answer will remain same. Derivative of e raised to x is e raised to x. Okay. Now let's see one more important rule regarding the derivative. Okay, that's called chain rule. It's very important rule. Okay, chain rule. When two functions are given as a when any function is given in a composite form, okay, in the composite form, let's say f of x is given in the form of f of g of x. Okay, it is called f of g of x. So two functions are there. This type of function is called composite function. So to carry out the derivative of this kind of function, composite function, okay, now let's say d by df of f of x. So how we can carry out the derivative of this kind of function? First of all, you need to carry out the derivative of this function f. So it will be f dash of g of x, and then carry out the derivative for g of x. So this will be d by dx of g of x. This dash means derivative. This dash means derivative. Okay. So right now it seems a bit complicated, but we'll solve few examples regarding the composite function and you'll clearly get the idea. Let's write down the examples of composite function, how the composite function seems. Okay, let's say sine 2x, then cos 5x, then let's say ln 10x, then let's say e raised to 5x square, then let's say 4x square plus 3 the whole square, then let's say sine 4x square, then let's say ln 5x plus 2, then let's say e raised to 10x plus 1. So this all are composite function. You can see here one trigonometry function is there, sine, and another is algebraic function, that is 2x. So likewise here logarithmic function is there, here it is algebraic function is there. So this type of function are called composite function, and to carry out the derivative of this kind of function you need to obey the chain rule. Okay, now let's see the generalized equations for the chain rule. Okay, let's say d by dx of f of x the whole raised to n. Okay, so here power is there as well as f of x is there. So the formula will be n of f of x raised to n minus 1 dot d by dx of f of x. Okay, the second one is d by dx of ln f of x, then it will be 1 upon f of x. Okay, this is for the ln. Okay, that's ln x, then it will be 1 by x, ln f of x, then it will be 1 by f of x, and then carry out the derivative of f of x. Then d by dx of e raised to f of x, let's say, then it will be e raised to f of x as it is, and then carry out the derivative of f of x. Then for d by dx of, let's say, sine of f of x, then it will be cos f of x dot, then carry out the derivative of f of x. And similarly we can write it for e, d by dx of cos f of x, it will be minus sine f of x dot d by dx of f of x. So these are the very basic equations for the differentiation. If you want to learn the differentiation, then you must need to remember this all formulas. Just take a screenshot of this and write it down in your notes. Okay, and please learn these formulas to learn the questions and understand the concept really well. Okay. Okay, now let's solve the first question. First question is y is equal to 7x square plus 10x plus 5. We need to find out the derivative. We need to find out dy by dx. Okay, so apply derivative to all the three. Dy by dx of 7x square plus d by dx 10x plus d by dx to 5. Okay, so it will be like this: 7 into d by dx of x square it will be like this, 10 d by dx of x, and for the constant it is 0. Now carry out the differentiation of this 7. So apply the formula nx raised to n minus 1. Okay, nx raised to n minus 1. So it will be 2x raised to 2 minus 1 plus 10. Derivative of x is 1. Here it is 0. So this will become 14x plus 10. Okay, so it is like, so this will be the answer, dy by dx, 14x plus 10. Okay, let's solve the second one. Let's consider the question y is equal to root x plus fifth root of x. Okay, so let apply dy by dx. So it will be dy by dx of root x plus d by dx of fifth root of x. So can we write like this? It is x raised to 1 by 2 and this is x raised to 1 by 5. Okay, now carry out the derivative. 1 by 2 x raised to 1 by 2 minus 1 plus 1 by 5 x raised to 1 by 5 minus 1. So this will be 1 by 2 x raised to minus 1 by 2. This will be 1 by 5 x raised to minus 4 by 5. Here we can write the answer as 1 by 2 root x. We know the derivative of root x is 1 by 2 root x, and here it will be 1 by 5 raised to 5 into x raised to 4 by 5. Okay, so this will be the value of dy by dx. Okay, just apply the formulas, remember the formulas and just apply the equations. Okay, now let's solve the third one. Let's consider the question y is equal to x square sin x. Now you can see here algebraic function and trigonometric function both are there in a product form, so we need to apply the product rule. Okay, so to find out the derivative of this, let's say first of all we'll keep x square as it is and then d by dx of sin x, then we'll keep sin x as it is and d by dx of x square. Okay, now what is the derivative of sin x? The derivative of sin x is cos x, so it will be x square cos x. Now what is the derivative of x square? So it will be 2x sin x dot 2x. So our answer will be x square cos x plus 2x sin x. You can also take x as a common, so it will be x into x cos x plus 2 sin x. So this will be dy by dx. Okay, now let's solve the next one, fourth. The question is y is equal to, let's say, cos x upon x square plus 1. Okay, if the question is like this, then how we can calculate the derivative, how we can carry out the formula? Dy by dx, it will be x square plus 1 the whole square, then keep denominator as it is and derivative of numerator. Okay, d by dx of cos x, then keep cos x as it is and derivative of denominator. Here it will be a minus sign, not a plus sign. Okay, just remember that one. It will be x square plus 1, derivative of cos x is minus sin x plus minus cos x, and this will be 2x plus 0. The derivative will be of x square will be 2x raised to 1, and this will be, for 1 it will be 0. Okay, keep denominator as it is, x square plus 1 whole square. So in generalized way we can write it as minus of sin x dot x square plus 1 minus 2x cos x upon x square plus 1 the whole square. So this is dy by dx. Okay, Okay, now let's solve the next question. Y is equal to x square plus 3 upon x minus 1. So for this we can calculate dy by dx is equal to square of the denominator, keep denominator as it is, d by dx of x square plus 3 minus of x minus 1, x square plus 3 as it is, and derivative of x minus 1. So it will be x minus 1 and derivative for this will be 2x plus 0 minus x square plus 3 and derivative for this will be 1 minus 0. X, for x it will be 1 and for 1 it will be 0. Keeping denominator x square minus 1 the whole square, so it will be 2x in bracket x minus 1 minus of x square plus 3, it will be x minus 1 the whole square. Okay, you can operate the bracket and solve. 2x square minus 2x, then minus of x square and minus 3 upon x minus 1 the whole square. Okay, so 2x square minus x square, so it will be x square minus 2x minus 3, x minus 1 the whole square. Now, so this is the value of dy by dx. Okay, now if you want to factorize it, you can. Okay, so you can write the answer like this. Okay, the factor for the x square minus 2x minus 3, it will be x minus 3 and x plus 1. Okay, so this can be the answer. Okay, this will be the answer. Now let's solve the next one. Sixth question. Y is equal to sine 2x. So now you can see it is in the composite form. Okay, y is equal to sine 2x, it is in the composite form. So first of all, carry out the derivative of sine. So derivative for sine is cos 2x. Okay, keep the function as it is. Okay, cos 2x and d by dx of the function, that is 2x. So dy by dx will be, the derivative of 2x will be 2 only, so 2 cos 2x. This will be the answer. Let's solve the next one. Y is equal to cos 5x. So dy by dx for cos 5x. Now derivative, it is again a composite function. So derivative of cos is minus sine, so it will be minus sine 5x and carry out the derivative of 5x. So this will be 5. So answer will be dy by dx is equal to minus 5 sine 5x. Let's see the next one. Okay, y is equal to ln 10x. So again it is a composite form, dy by dx. So it will be, what will be the derivative of ln? It is 1 by x. So here it will be 1 by f of x. So 1 by 10x, and then carry out the derivative of 10x. It will be 10. So dy by dx is equal to 10 upon 10x. So 10 will get cancelled out. So answer will be 1 by x. Let's solve the next one. Let's say y is equal to 4x square plus 3 the whole square. So dy by dx. Okay, first of all you need to carry out the derivative of this power, and then this function you need to consider. Okay, so carry out the derivative of power, that will be 2 in bracket 4x square plus 3 raised to 2 minus 1, and then you need to carry out the derivative of this function. So this will be d by dx of 4x square plus 3, right? So derivative for this will be 4x square plus 3. So derivative of this will be 4 into 2, 8x raised to 1, and for this 3 it will be 0. So 8x, so we are getting 2 into 4x square plus 3, here power will be 1, and here we are getting the answer 8x plus 0. Okay, so multiply 8x with 2, so we'll get the answer 16x in bracket 4x square plus 3. So this is the answer of dy by dx. Okay, let's solve the next one. Y is equal to sine 4x square. So here dy by dx, again it's a composite form. So derivative of sine is cos, so it will be cos 4x square, and then carry out the derivative of 4x square. Okay, so it will be derivative of 4x square, so it will be 8x. Okay, so 8x dot cos 4x square, this will be the answer for this one. Now let's solve the next one. Let's say y is equal to ln 5x square plus 3x. Again it's a composite form, so dy by dx, first carry out the derivative for ln, so it will be 1 upon 5x square plus 3x, then carry out the derivative for 5x square plus 3x. So dy by dx, derivative of this will be 10x, and for this it will be 3. So it will be like this, 1 upon 5x square plus 3x, and for this it will be 10x plus 3. Okay, now let's carry out the another equation. Y is equal to e raised to 5x square, derivative for this will be, see, for exponential function the derivative remains same, so e raised to 5x square, and then carry out d by dx for 5x square, then it will be e raised to 5x square, and derivative for this it is 10x, so this will be 10x. So our answer is 10x dot e raised to 5x square. This is dy by dx. Okay. That's all. Few more questions. Let's see the next one. Y is equal to e raised to 10x plus 4. Okay, so dy by dx, it will be e raised to 10x plus 4, and derivative of 10x plus 4. So this will be e raised to 10x plus 4, and for this derivative will be 10. So answer is 10 e raised to 10x plus 4. That's all. The next one, 14th. Y is equal to x square plus 4x plus 6 raised to 5. Okay, so it is again a composite function. So dy by dx, first of all carry out the derivative of this power, so 5x square plus 4x plus 6 raised to 5 minus 1, and then carry out d by dx of x square plus 4x plus 6. So derivative for this will be 2x plus 4. Derivative for this will be 2x plus 4. So 4 in bracket 2x plus 4 raised to into x square plus 4x plus 6 raised to 4. So this will be the answer. Okay, let's solve the last question, that is 15th. Log 5x plus e raised to 4x square plus sine 7x. Okay, let's consider over cube over here. Okay, let's say now this type of question is there. Okay, so we need to find out the derivative of individual term. D by dx of log 5x cube, then d by dx of e raised to 4x square, and then last d by dx of sine 7x. Okay, now let's calculate the derivative for this one. So it will be 1 upon 5x cube, then d by dx of 5x cube, plus derivative for e raised to 4x will remain e raised to 4x, and carry out the derivative of 4x square, plus derivative of sine is cos 7x, and carry out the derivative for 7x. Okay, see, now derivative for this 5x cube will be 15x square, so it will be 15x square upon 5x cube, plus here the derivative for 4x square will be 8x, so it will be 8x into e raised to 4x square. Derivative for 7x, it will be 7, so it will be 7 cos 7x. Okay, 7 cos 7x. Now we are cancelling this one, 5 ones and 3s are. Also here you can cut it down. So this term will be 3 by x plus 8x e raised to 4x square plus 7 cos 7x. So dy by dx for the given question is this. Okay, so I hope your concept is clear now regarding the differentiation. Okay, please like, subscribe and share these videos if you are really finding it helpful. Okay, I'll bring you more content like this for you, so keep watching, keep sharing, and stay tuned for the next lectures. Okay, thanks a lot.